Hi all, this is Claudio from FEA.com with a video lesson about modeling and analyzing a bridge. A brief reminder about our website, FEA.com, with lots of simulations, and fem.bio with biomechanics specific cases. Moving to the topic, we opened an older version, let's say, of SpaceClaim. We need to go in the plane view, and we're going to use a single point for the moment. You can see it here at the intersection of the, let's say, the coordinate system. Let's simply move it. Yes, we will select it here. With Control pressed, we will go towards the right with 10,000 millimeter. It readjusted the size of the screen. Let's repeat the command. With Control pressed, we drag the arrow and we write from the keyboard 10,000 millimeter. So we have 3 points, you can see it here in the model tree. And this is the last time that we do this. Until we have, yes, 4 points. Now, let's duplicate them vertically. With Control pressed, we drag the Z-axis for how much? Let's say 5,000, and let's do the same with all the points for 10,000. Alright, so we have an array of points here. If we are here on the moving side, let's say that this is one side of the bridge, we will need to somehow offset this side about the y-axis. You will understand very fast in a few seconds. So we're on the move command, we select all the points, and we go on the, now it's called the z-axis. On the z-axis with Control pressed. For classic 10,000 millimeter. What remains is a very easy job now. Let's put on top, let's put the lines on top, yes. So, in order to create the beams, we need to define a profile. We will choose it from here. If we want to see the profile, we can right-click, edit beam profile. We see its dimensions. We can modify them later in ANSYS workbench. Let's close it. So, if we click the create, and the create command will work only after we selected the profile. If we click create, we can then draw all these lines. So let's escape. This portion, escape, create again. This portion. So we will have 3 main regions, let's say. we can continue now with the main beams, let's say, with the ends of the bridge. Escape, create again. And we will need, let's say, create again. Let's make it from here. Alright. Let's repeat the same method. Escape, create. Escape, create. Now we put here a beam. Alright. So let's continue with the beams. Escape, create. I would like to make like a cross here, like an X. Escape, create. Again, escape, create from here to here. Everything is very easy at this point. And the last beam, let's say. Alright. If we select two lines, we can somehow position ourselves into a sketch view. So we selected these two lines and we have here a sketch mode, yes? Let's go to plane view. What I need is to create like a slab or a floor for this first portion. Let's click the rectangle and we will make sure that we snap exactly what we did here. Escape. Let's repeat the operation. In order to position ourselves on the same plane, we will click the surface that we just created and click sketch mode again. Let's repeat the rectangle drawing. Here to here. Exit. Now let's do the same for the third portion. Let's click here, we go to sketch mode, we position ourselves to the plane view, and we will draw the rectangle. Which by coincidence, let's say it's a square after all. So we have somehow, yes, the main portion, the main feature of the bridge. Let's make a few more beams. And here, escape, create. So we have these regions. I'm not convinced of the, let's say, the structure integrity here, so let's create another beam like this. So do we leave it like this, or should we make here also? Let's not overcomplicate it. We can say that the model is done. I would like to give you a big reminder. This was made because I didn't press escape in a certain moment. Let's delete it for the moment. So let us save the file. We'll call it bridge 1. And let's go to ANSYS workbench in order to verify the integrity of the 3D model. The easiest way is to perform a modal analysis. Yes, of course. I'd like to give an important reminder when working with beams and extracted beams in SpaceClaim. Let's wait a little until ANSYS workbench opens. It takes a few seconds until it communicates with SpaceClaim. So this is our model, yes? Let's imagine that this is somehow the floor, and it has a thickness of 10 mm structural steel. These are our beam portions, yes, beam members. Let's generate a default mesh. Can we do it? Let's do it final. Let's switch to meters in order to properly assess what occurs here. So, what we will do is we will, for the beginning, we will fix the bottom nodes, let's say. Supports fixed. Here we select node and we change the selection to box select. If we move a little, we can see that all the bottom nodes are selected. Apply. I think maybe we should select the vertex. Yes. Let's choose here, I don't know, maybe 25 maximum modes, and let's ensure at least 8 cores. Yes, we have 8 cores here. We will save the project. Bridge 1. Go here. SpaceClaim doc. Alright, let's solve. Where should it go from the first time. But the last time it worked, yes? So, what you can see here is that we have some erroneous or wrong frequencies, yes? We can somehow bypass them. If we click here, limit search to range, and any value, yeah, besides, let's say 0.01. Anything that is not 0, yes? But this is a warning sign. We do not need 0 mode or 0 hertz frequencies, yes? Let's solve again. You see, we bypassed the 0 modes, and we have now everything here. The easiest way is to right-click, select all, right-click again, create mode shape results, and here right-click, evaluate all results. Let's save. Now we can see what occurs here. This is what I wanted to highlight here, yes? The fact that the sheet, the surface is not somehow bonded or connected with the beams. This is only the sheet that is, let's say, dancing around. What I want to show you is also the beams that which are not correctly connected here. And in order to show you the behavior of the beams, the wrong behavior of the beams, I will suppress the surface, because many of the frequencies will belong only to this shell part, and we don't need it for what we're going to prove right now. Let's go to solve again. If these are somehow connected, I would like to show you that it's not the case here. Yes? Look here. So this beam just floats away. Also this beam, also this beam. Yes? There are many beams, and yeah, they are not somehow connected. Why? Because they do not have a common node. They have different or separate nodes. I would like to show you how to make them, let's say, connected in SpaceClaim. So where were we? Here in the bridge. This is the command that you need to remember when working with such geometries. Workbench, it's useful if you click and select faces and vertices. The command is share. Everything that somehow, yes, is coincident, I'm talking about vertices and edges, they should be common, or they should be shared by neighboring parts, let's say. So it's very easy. If we just click share, it will detect what is sharing here. Just accept it. There is no topology in the model. Yes. This command will also somehow bond, let's say, the shell body to the frame. You will see in a few seconds. So let's save the doc. We go to this solution. I would like to duplicate it. Nothing needs to be lost. We will duplicate here. And what we do here is update, in order to update the geometry with the newest version. It will take a little time because it communicates with SpaceClaim. Let's hope it's the proper geometry. I mean the updated one. We look here, and in order to verify what if it's the last geometry, we will just solve the FEA to see if we have dangling and dancing beams. Yes, it's the case. The beams are dangling and dancing and whatever they are doing in a wrong manner. Let's go here and right click, update geometry from source. If we go to project workspace, we see that yeah, everything needs, let's say, updated here. Let's go again and solve the FEA to see if we if everything is connected now. Why should it go? Why should it go from the first time? So something is not right here. In order to obtain an independent file, we need to go right-click source, internalize all, and we will not have versions of different files. Yes. Let's check here if we have share. Yes, there is no coincident topology. File save as. Instead of bridge 1, let's choose bridge 2. We will go here, replace geometry. Do you see it now? Yes. So the entire, let's say, frame truss it belongs to one body now, and I have the surface here. Let's unsuppress the surface. We have the beam, the centroid. If needed, we can, as I said in the past, I think, yes, in the newer versions we can edit this section, the dimensions. Not 19, but I bet I can edit in 2019, 2020, 21. File save. Let's just solve. For fun, let's put here what was in the beginning. Let's not filter anything. to see if we have wrong modes. If we have 0 frequencies as a result, as a resonance, then the modeling was not successfully done. So let's solve. You see, we don't have 0 modeling solution. When we animate now, everything kind of makes sense, but we have only one node here. Let's reselect these bottom nodes with the box select. So we're sure that everything is fine now. Save project, solve. So, look how nice it looks. I'm interested a little in this portion. But it looks nice. Nothing is dangling, nothing is flying away. So it looks very nice. This is the best way to ensure, let's say, like tightness and the correctness of the model. For the next scenario, I would suggest to open a static structure, insert the same geometry, and we will simulate like a moving load, or let's say like a column of cars or something like this. Let's close SpaceClaim. Units. Let's go back for the moment with the millimeters. 10 millimeters. Steel, beam, we will leave it like this. Can we edit? We can't edit. Yes, okay, this is an old version, so I advise you to work with a newer version than 19. Ideally, it would be 2021. We can observe that there is no connection made, let's say. And here we will, because we will move the load, let's say, on each portion, we will prescribe 3 steps. Large deflection, for the moment, let's leave it like this. We'll put a force. 10,000 Newton with minus. So the row of cars will begin to travel from, let's say, from the right side to the left. This means we'll need here 0, 0. Let's duplicate. We select this face. Here we act in the second pace, second step, let's say. Let's duplicate and we select the third face. again, this is the last portion which is loaded, let's say. So let's make again the fixed support. We select vertices, box select, we verify everything looks fine for the moment. We have 3 steps, 1, 4, 2, 3. Alright, looks fine. Let's go here to deformation, strain, stress, and I would like a force reaction in the fixed support. There is a beam tool here. Let's put it for information. Do we have something? We do have direct minimum and maximum. Let's go to maximum combine. We have bending. For the information, we have total and directional. Combine. Let's put bending if it's possible. Maximum bending stress. And for deformation total. We're going to save before solving. Let's see if it works by default or if we need to refine the time steps. Huh. So fast. Yeah. It looks nice. 1, 2, 3. So, because the deformation is very large, it might be a good idea to change from the large deflection off to large deflection on. Alright? Before doing this, let's look a little on the stress. 25 megapascals. It looks very nice. Yes. Total deformation, bending stress. So you see now we can scope for the stresses in the beams. Yes, the default equivalent stress does not work, is not scoped to the beams, but if we select the beam tool, we can see the stress in the beams or the various types of stresses. So let's run the nonlinear part. Then we can say that the scenario is finished. Save. We can write here for the setup. Duplicate. Now we will make large deflection on. Let's remember that this is the bridge 2 file. We can confirm here. Now it belongs to the ANSYS structure. Let's write here bridge 2 file in order to remember what we are dealing with. Alright, so double click. So this is the new FEA. We don't need section planes. Let's go to ANSYS settings and change from off to on. let's see if it just works. What do you know? It just works. So let's believe more in these results. Because the deformation was too large to ignore it, let's say. And for the last part, let's input and let's see what occurs with a nonlinear material. And we will have the maximum, let's say, nonlinearity in the model. We'll select nonlinear steel. We see it that now it's in our library. Double click, update. Let's remember to rename here to on. Yeah, F2 is for renaming. Just press F2 from the keyboard and everything is very easy. Save. We will instead choose structure style nonlinear here and also here. Let's see if we encounter problems or if everything works fine. So everything went just fine. We have similar values to the previous scenario, so we have a very reliable model now. We will save everything and the customers who will purchase these already made scenarios will receive all these scenarios already made, everything. Thank you for your attention, and we hope it helps you in your work and research. Have a nice and superb year 2022. Bye-bye.